Hello everybody, welcome back to Wild True Learn. I see a sticky note here, bid data equals big mess. It's not big data, it's bid data. I don't know what that means. Anyway, let's continue on to the next task, Solvency Assessment. Client's Solvency Assessment. Good afternoon, we represent the Money Bag Bank. We want you to create a system for sorting candidates applying for loans. We believe that cold, soulless mind of a machine will help us save more money than our regular empathy-corrupted human clerks. We would very much appreciate it if you'd complete the task before the holidays. Alright, deep news. Semi-supervised learning. Semi-supervised learning is used on partially unlabeled data with unknown answers. Typically, a machine learning model predicts answers for unlabeled data and uses this prediction to improve. This method can improve quality of the model even when the data is not completely reliable. In real life, adding 5 to 10% of unlabeled data leads to minor quality improvement, and adding more data of this type spoils the model. Okay, we want just red and green. We have 3 red and 40 green. Okay, so we need to blend in some inaccurate ones. Okay, for red, how about we just do exactly 3 red, and then for the green we can mix in some blues. Now we could afford to put all the blues in here. So I'm thinking blue, green, or I guess green first, and then blue. For the red, we can only afford to put 3 reds because with 75% accuracy, the maximum we can put is 1 item that's not red. And so we have way too many green and blue, so we don't really want any of those. But for green, because we have 40 of them, we can afford to put 10 more, or even more. We can afford to put 12 more items of other colors. And so if we can, if we just pass all the green and blue in there, I think that would work. Yep, perfect. Okay, next one is Raging Birds. Raging Birds from the Sky. Dear computer specialist, you gotta help me. I own a miniature pig farm and also have a crazy neighbor. He enjoys making bird-shaped shells out of paper mache and throw them at my piggy's sheds. He makes all kinds of shells, tiny red round ones, triangular, the square ones, you name it. I'm constantly rebuilding my sheds so they would be impenetrable by those birds, but I need to be able to know the shapes of shells that wacko's using. Can you please write an algorithm for that? Okay, here's everything except triangles, and everything only triangles. And then we need, 40 triangles, 20 of other shapes, and then these can accept whatever that's left, but with 10 and 30. Okay, we need 1, 2, 3, 4, that's 100. And we have 180, so we can afford to waste some stuff. 47 seconds. Yeah, we definitely need to parallelize this because sift takes more than 1 second. Okay, so let's see. Sift takes 1.1 seconds, 47 seconds, so it looks like we have time to do about 40 of them. And we have a total of 180. I think it would need about 160, so that's a 4-way balancer. So let's start with that. And then we can do, we pretty much want to collect all the triangles, don't we? Let's see, if we have, yeah, we can do 3/4 of all the triangles. That would work too. But yeah, let's do triangles. Go in here. We have about 40 of those. If we have 40 triangles, that would make 80 of the other shapes. Yeah, I mean, okay, let's do it this way. We have 15 triangles, 1/4 of the triangles coming in this way, which means we're gonna have 25 and 5. 25 and 5 makes about 30, or we can do this. That'll satisfy pretty much everything. We have triangle. Let's just try to distribute them. So in this case, we still want the triangles to go here, other shapes going here. Triangles go here, other shapes go here. Okay, and the last one. Triangles still go to the triangles. Other shapes go to the output that requires more. Let's see if that's good enough. Not quite. The top is not getting enough items. Okay, if the top is not getting enough items, as I said, we only need 40 out of 60 triangles. So maybe if we don't even send the triangles... Wait, what am I doing here? Wait, triangle should go here. Other shapes go up. Did I just get that wrong? Okay, I'm doing a lot of stuff wrong, aren't I? What was I doing? Okay, hold on. Triangles go there, other shapes go to there. Triangles, other shapes, triangles, other shapes, triangles, other shapes. Okay, at least our accuracy is looking good. Our item numbers are looking okay too. The top one is still a little bit slow, it seems. Okay, we got a silver medal. That's not too bad. Okay, so the top one is still too slow. We're gonna do this so that we send all of the triangles up here. See if that's any better, but then the triangles might slow down too much. Yeah, we got all of them except the triangles still need processing. Yep, that's too slow now. Okay, is there a way we can speed things up? Okay, here's an idea. The triangles only require 90% accuracy, so we can actually mix some other shapes in there. So what we can do is we'll look at which one, we'll restore this one, because we need the triangles in here. Wait, hold on. No. Okay, we'll look at which one fills up the fastest. I'm thinking it's this one. This one's going to fill up the fastest. Or no, this one's filling up the fastest. Okay. we got this. So this one's filling up the fastest. I'm thinking we're gonna divert some circles from here to the triangles, because we have a small number of circles. The small number of circles might be okay to pass in here and still meet the accuracy rating. And even if we divert some small number of circles from here, it's still going to meet the occupancy requirements because this one was filling up fast. So we're going to do squares, and if it's a square, we're going to pass it in here, but otherwise it could be a circle or a triangle. We're going to put them down here. Okay, yeah, maybe I should put the triangles down here now. In that case, I think it was the top one that's filling up incorrectly. Okay, yeah, the top one is getting too slow now. In this case, I don't even think the bottom needs any help. Okay, what if I do this? The top should have enough items, and then I will do a couple more. So maybe even this one sends its circles down to the bottom. Triangles are way too slow, and it's not getting accurate enough. Okay, so maybe sending triangles up here was not a good idea. I'm going to keep the triangles like this, except the top now needs more shapes, I'm pretty sure. Let's reset it back to what we had before, the proper way of doing it. Triangles go here, else top lane, triangles go here, else second lane, triangles go here, else third lane, triangles go here, else third lane because it requires 30. So maybe all I do is... Okay, I'm already using the maximum number of nodes allowed. So it's just a matter of distributing the shapes appropriately. Let's test this again. I want to remind myself how everything is going. Okay, so the 10 items is filling up very quickly. And then eventually... Oh. What? I don't know what changed. That's weird. Pretty sure we had this configuration right at the beginning. I mean, some of these were assigned differently. Like, I was assigning the bottom to the top, and then maybe this one to the third one or something like that. But because these are balancers, they should be evenly divided. Maybe it has to do with exactly how the triangles, how the order in which the shapes come out of the input side. Let's test this and see if that works. So I'm pretty sure we had exactly, well, pretty much exactly this kind of setup before, and it wasn't working before. Yeah, see, now the top is missing items. It's a different result. If I send this to the top and see, 1, 2, Oh, that's wrong. No, I meant send this to the top and then send this one to the third. It's still the same setup, right? Because every sift is doing exactly the same thing, and it shouldn't matter where I send the outputs. Let's test this again. Yeah, okay. That's a bit annoying. So, yeah, sometimes even with identical setups, it seems like the order in which you place the nodes actually matters. So that's pretty annoying. Alright. Elite Conference. Greetings. Our scientific conference provides several lecture halls for visitors to meet famous scientists. We would like to separate VIP badge holders from the rest, but unfortunately VIP halls have a very limited capacity. Therefore, some of the premium badge holders will have to be sent to regular halls. We have a terminal that helps visitors find the way to the respective room, but it has to be updated. Would you kindly do that for us? Okay. All circles, everything except circles, and only green. Okay. So 15, 20, 10, that's more than we need. Looks like we can put all the greens over here and then separate by shape all the circles here. So it would have red circles and blue circles, no green circles, because we're putting all the green circles down here. Or something like that. So yeah, decision tree first to get all the green colors. So we have red and blue, sure, why not? Green, green. This is our standard setup for sorting things into 3 colors. All the green go in here. All the red and blue can go into a sift. Oh, I'm using more nodes already. Okay, it doesn't like that. If I do this though, it might be too slow. I'll just try it. Okay, yeah, and the shapes are filling up way too slowly because sift is very slow. That's right. Instead of picking out explicitly all the green, we can do this trick where we do green and any. That way we can pick out a subset of green. We can pick out about half of the green, which is more than enough to satisfy this output. And then the rest we can put into a balancer and have 2 sift nodes in parallel. Excellent. Alright, and then next we have a new startup blood center, and for this I'm gonna save the game first. Just because the game doesn't let you retry the startups, so if I fail I can still load the game to try again. And even before that, just check our inbox, because it looks like we got more emails. Letter from a friend. Hey, what's up buddy, how are you? Listen, I know I wasn't paying you for quite a long time, and I'm very grateful that you weren't demanding for a paycheck for so long. But to be in debt, even to a friend, is not cool at all, right? Therefore, take this money you've honestly earned. Thank you, friend. You've really helped me out. Yeah, and how about we go to a concert next week? Oh, that's nice. There's a friend that owes me money, apparently. Okay, and we have stuff in the seabay that we can buy. There's still the 40,000 thing. Long on a shelf. Good for generating oxygen in the room. Guess that'll replace my cactus. cat's joy in case you run out of food. Cat grass. Hawaiian room decor, sweet dreams. And dummy, scientific assistant. What is that? Seems like a whole bunch of gizmos linked together. Okay, nodes, we can buy the nodes, random forest. Sure, why not? And then hardware. JNTEL network card increases data transfer speed. Okay, and we just ran out of money. But still very, very cool. Here's our cat grass. What else is new? This is our little bot. Oh cool, this is our Hawaiian theme. Ooh, sunset. Looks nice. Okay, I think that's about it. Alright, let's save again. And then we will go to our startup. Blood Center. Not enough money. Oh. Okay, I just played myself. Oops. Alright, let's do the next one. Presidential elections. We will come back to the startup once we get more money. Good morning. I need to know who to vote for. Can you predict the winner of the next presidential election? I will send you a big database. Doesn't that kind of defeat the purpose of voting? If you're just gonna vote for the winner, that's not really how elections work. I will send you a big database. Okay, random forest. In the game, this node compares color and shape of an element with each of the sockets and selects the one with the least amount of errors. If there are several matching sockets, a random one is selected. In the real world, a random forest is a composition ensemble of several decision trees. In real-life tasks, the number of trees can reach up to several thousands. Each tree can distinguish several classes, but they were trained on different parameters and classify objects based on different characteristics. When a prediction is required, a forest asks for the class from all trees and chooses the winner by voting, picking the most popular answer. Okay, 68300, we need to get all of the blues. Or do we even need to get all of the blues? Okay, so we do need to get all of the blue. We need to get some number of the blues, but it only requires 80% accuracy. 80% is... Okay, we can have one error in 5. And so, yeah, we can't just take every single thing. But we can do... We'll take out all the green. We'll trash all the green and some of the red, and we'll put all the blue there. And 0.27 seconds for 300 is definitely not going to finish in 26 seconds. I'm thinking even if we put a balancer here, it might not finish. Copy, paste. It might just be too slow. Yeah, that's not even close. Okay, how about instead of throwing away the green ones, we throw away the small number of red ones and half of the green ones. So we'll have 40 green ones mixed with 300 blue ones, and that'll still be decently accurate. But I think it's still too slow. We're not going to be able to do that within 20 some seconds. That's pretty crazy. Well, given that the decision tree is too slow even to classify half of the items, why don't we allow some more incorrect items. So with the balancer, we can allow half of the items to come through completely unfiltered, so that'll give us about 150 blue and 40 something other items. That won't exactly satisfy the accuracy, but we also have this other route that's going to filter things correctly, leaving very few, just 1 or 2 red items coming in over here, with the vast majority being blue. And I think that's still going to meet the accuracy target, but this side is going to be much faster, so it's going to get more items in the allotted time. Let's try that. Oh, we're getting there. 27.2, just a little bit too slow. And we're at 81% accuracy, so that was still okay. How do we make this even faster? I mean, I guess we could. So the problem is, the more items we have to process through the decision tree, the slower it's gonna get, right? So what if we cut that down by another half? So now we're putting 3/4 of these items directly into the output stream, unfiltered, and then only 1/4 of the green items get filtered out. So that's actually, if we filter out 1/4 of the green items, that's 20 green items down, which means we have 60 green items compared to 300, which is actually 1/5. So that might be okay. Okay. Yeah. Okay, that's a neat trick, I guess. Alright, now let's move on to Blood Center. We will finish off with the startup. Still not enough money? Investment 3,000. Okay, never mind. Do we have anything in our inbox? It's just a startup? Okay, well, I guess we'll leave it here for this episode. Next time we come back, we will do the startup. We have 2 startups and 1 more task before we finish this section. So that's it for this episode. Thanks for watching. See you next time.